Hi, this is supplementary math lesson for advanced math, lesson 75 combinations. So what we are going to do for the remaining 2 weeks of our class in advanced math is we're just going to focus on some statistics types things. So I've kind of went through and selected all of the sections involving statistics for the remainder of the book. So we're already at where we need to be for advanced math for the end of the year. So we made really good progress during the year. So we're just going to kind of coast here the last 2 weeks. You have some rather simple homework assignments involving statistics. And so it's a look at an area of math that's a little different than algebra, than trigonometry, than geometry, and it has its own special equations. And with our project, we'll see how the usefulness of it. We're going to be watching those crash course videos on statistics as well. So just to give you a flavor, if you're going to go on beyond advanced math 1, you'll have more statistics, but in college, statistics is usually a separate course, and as a math course, it's usually easier than definitely any calculus type of courses or things like that. And I think Nolan even mentioned that he's taken an online statistics course, so he was kind of familiar with these things. So, and that's an option for you too. Many, colleges have that as a core requirement, statistics, just so you become familiar with how to use, especially, like things here, probability, permutations, combinations, and then that normal distribution and standardized normal distribution curves are really prevalent in the field of statistics. So you should know a bit about those in any area of life, really. So just definitional wise, keep things straight. I've identified outcomes, and that was introduced as a term in your statistics project. We'll actually get to it in the next lesson involving probability. And so that's just how many events can occur in a given situation. And these problems involving dice and involving cards are a little bit different than ones. Those deal with probability, and I don't know why they didn't introduce probability first. It's usually a more easier term to grasp in statistics, but they decided to go to permutations and combinations instead. So, but basically, we'll get into outcomes in the next lesson, but in the example when we were rolling our dice, okay, how many possible outcomes can we get when we roll 3 separate dice? They're identical dice, and we want to keep track. If we could, let's say they were colored differently so we knew which one was the first, second, and third dice, how many possible outcomes could we roll with that dice? Well, the first dice, we have 6 possible outcomes. Okay, when we roll the second one, they're all rolled at the same time. Okay, it has the same 6 sides, so we have 6 possible outcomes for there, and the third dice the same. We have 6 possible outcomes. Okay, so our total possible outcomes, 6 times 6 times 6, equals 216 possible outcomes when we roll a dice. If we're worried about what order they're rolled in, and whether what's the first one returns, what the second, and what the third one. And they may repeat. Okay, we may roll a triples, we may roll a doubles involved there, we may not. They may be all different. Okay, but there are 216 possible outcomes, and that was the first exercise. I should go ahead and listing all of those. Okay, I could roll a 1, a 1, a 1. A 1, a 1, a 2, a 1, 1, 3, all the way through. So you had to list out those 216 possible outcomes. Okay, now the book defined permutations, and that had to do more with picking things from a group and in what kind of order would they be in. So we're in, excuse me, we are interested in order, but with permutations, unlike with the dice, we are not allowed a repetition of an individual event. So in the case of permutations, okay, if we take it as the dice, we take it. We have 6 chances to roll something on our first roll. Now we do not have the possibility of repetition. That's just kind of definitional wise with permutations. Okay, so there are 5 possibilities on the second roll. Okay, and then the third roll, again, we are not allowed repetition of either the first or second number rolled. So that reduces the possible outcomes of that third die to 4. Okay, so then we say the permutations are 6 times 5 is 30 times 4 is 120. And of course, they've introduced a equation to do that, so we don't have to do this box things here anymore. And we see what happens when we put it into that equation. Okay, so well, what are we want the permutation, capital P, of n events, n things, taking r at a time. Yeah, I don't know if that helps you to understand what's going on, but basically the n is the total individual possibilities, okay, being 6. Okay, and the R is taking them. How many times are we taking them? Well, we're taking them one because we have 3 different dice. We're picking 3 times. Okay, if we had the dice in a bag and we picked one and see what the number read, okay, we picked the second one. That R represents the number of times we're doing that. And of course, in permutations, we're not allowed the repetition. So that leaves us. So in this, the 6 will be our n. Oops, excuse me, my chalk. The r will be the 3. And again, you can practice putting these into your calculator too, okay? And or you could write it out in equation form. And I think I mentioned to you earlier, in your probability button, if you don't have that factorial thing on your front screen, it will be buried within the probability function button of your calculator, okay? So, and just remember this, okay? The big number always has to be the first number in this equation, and when you punch it into your calculator. So for me, what I have to do is I have to punch in the number 6, then I hit the probability button, the PRB, then I have to scroll over to this notation where it's underlined, and I hit enter. And then I hit the second number 3, and then it enters. And it actually enters 6 and 3 into this equation here, where it would be 6 prime, or 6 factorial, I should say, over 6 minus 3 factorial, okay? Or 6 factorial over 3 factorial, okay? And that equals 120. Okay, either way. So whether I do it this way, 30 times 4 is 120, or I just plug it directly into the equation, or practice on your calculator so you can get it to come out that way on your calculator too. Okay, and so combinations this lesson. And it also alludes back to lesson 55. They say, okay, permutations take into account the order, excuse me, order. But what if I have things that I'm picking that I can't distinguish from each other? Okay, they gave a method to go ahead and do that. They called it distinguishable permutations. And think of it this way, okay? So when I have a permutation of rolling 3 dice, it can't have a repetition. Let's look at a permutation that involves rolling a 1, a 2, and a 3. Okay, now outcomes wise, I could, if I rolled a 1 first, I could roll a 1, then a 2, then a 3. I could roll a 1, a 3, and a 2. Okay, if I rolled a 2 first, I could roll a 2, a 1, and a 3, a 2, a 3, and a 1. And if I rolled a 3 first, I could roll a 3, 1, 2, a 3, 2, 1. Okay? Now, they're all different outcomes, okay? And in this case, they are all different permutations, okay, because they involve the order matters, but there's no repetition involved. They only involve a 1, a 2, and a 3. But what a combination is, okay, effectively, if they're all the exact same dice, and there's a 1, 2, and I roll them all at the same time, okay, and they're on the table, I can't determine, okay, exactly what order they were rolled in. Okay, which dice I'm calling my first dice, which I'm calling my second, which I'm calling my third. All I see is a 1, 2, and 3. Any of these 6 permutations, to me, look all the same. It's a 1, a 2, and a 3. Okay, and so that's really what the definition of combination is. Okay, so it's taking our permutations and it's it's taking into account if I can't distinguish the individual event one from another, okay, it takes that away. And so let's look at it here. In the case of the permutations, where it only involves a 1, a 2, and a 3, I have 1, 2, 3, 4, 5, 6 possible permutations, okay? But as far as combinations, how many combinations do I have? I only have 1, okay? That has reduced my my number by 6, okay? And effectively, that's what this new equation in the book does for us, okay? It's saying the combinations possible is the number of permutations divided by, okay, the number of items that are similar in those individual events, okay? Well, what are the similar items? In this case, it's the 3 dice. I have 3 dice exactly similar, okay? So if I plug it into that equation, it's 120 permutations over 3 factorial dice, or 120 divided by 6, and that equals 20, okay? So in rolling 3 dice, either one at a time or all 3 at the time, okay, my outcomes, 216 possible outcomes, okay? My possible permutations are 120, okay? What does that not count? That does not count if I roll a triples or any doubles, okay? Because in permutations, I cannot have repetition, okay? And then what are combinations? My combinations are 20. Okay, in those permutations, which do not include doubles or triples, okay, how many combinations are actually distinguishable from another? Okay, I noticed here I had 6 permutations, but only 1 combination, because I can't distinguish any one of these rolls from another one when all 3 dice are on the table and all the dice are exactly. Okay, so when I do that, I see my actual possible combinations is only 20. 20 combinations possible, and that means where all 3 dice are different numbers, okay? And it doesn't matter the order that they're rolled in. And that was the drill, excuse me, going through your statistics project and arranging the combinations, the number of combos for the sum of the dice. That's what you were doing here, okay? You were actually seeing how many actual combinations were there. That was the drill, and I'll explain more of that when I get the statistics projects in. I'll do a video reviewing those, okay? So just kind of wanted to go over those 3 definitional things, how they differ, what they actually statisticians mean by them. So it's important. You have to know definitional wise what these 3 terms mean, okay, going forward. So your homework assignment is on the syllabus today. I hope this helped. And we'll be doing, I think you have a crash course video for tomorrow, so I'll send that out with questions to answer. Okay, so long for now. Bye.